All right, guys, welcome to section 5.1, where we are discussing, we're comparing linear and exponential functions and in some real-world applications. Let's get to it. Janice receives $2,500. She's going to put it in interest-bearing fund. The basic account earns 6% simple interest. So you want to say 6% simple interest at the basic place. However, at the gold bank, she can earn 4.5 compound interest. So you want to know is which is a better place to put her money. So simple interest, I'm going to use red. Simple interest, basically you're going to get her total. You want to write a function for each account, okay? So you could say, well, the function of her money, depending on time, okay, depending how long she has it there, is her original $2,500, okay, plus whatever interest she gets per year, plus her $2,500 that she has in a year, times her interest, which is 6%, and notice that 6% is 0.06 and not 0.6, okay? So it's not 0.6, not that. And then we're going to multiply that all by however many years she's getting that. Okay, so I'm going to put that. Here is the input time, T in years. So if she was there for 1 year, well, she's only going to get 6% of 2,500. If she was there for 5 years, then she'd be it'd be 5. This would be 5 times whatever this number is. So 6% of 2,500. I'm not really sure exactly what that is. I know that 10% is 250. So 5% is half of that, and 6% is close to that. Okay, so all they want is the function. All right, that is simple interest, okay, simple. Now let's use blue for the compound. The compound interest formula is you're going to have your, let's call it G, right, G of X, okay. It's instead of X, we're going to put time again. Time is the input. And she is going to get, all right, guys, continue. I'm sorry, I had to take a little break here. So we're doing the compound interest. So the compound interest is the original 2,500 times, I'm going to put it in red, 1 plus the interest rate and to the power of t, okay? To the power of how many years we're going to be doing this. So one of the easy things you can do is you can usually add this right away, so you don't have to leave it like that. You just make it faster. You can just say it's 2,500 times 1.06 to the t would be your function for your compound interest. All right, next, if you look at the B section, what the heck? I didn't save. Oh. All right, I'm not sure why it's not pasting it in there. So let me delete this, see if this will make. Hang on, guys. All right, so for B, the units in time is years, and the units of our savings is in dollars, not pesos or yen or euro. It's in dollars. And the expression for the savings at the basic place is that function that we came up with. So we'd have the 2,500 Okay, we have 2,500 times 0.06 times time, and then plus the original 2,500. So we have the original plus the interest times how many years we did. And on this side, we had 2,500, the original amount, times 1.06 to the t power. So you want to use your calculator to figure this out. Time zero is actually like now. What is it today? So we started with 2,500 in the very beginning, and then this one's 2,500. They're both starting at the same. And then 5 years from now, well, use your calculator. So basically, you're going to type 5 for t. Okay? So multiply 5. So I'm going to use my calculator. So it's going to be 2,500 times 0.06 times 5 years plus the 2,500. I got 3250. Okay. And the way I did it was I used my calculator and put this formula. I started from here. This times that times 6. I assume 5, and then plus the original. And the other one, you want to plug in t. You want to plug that number 5 into t. So you want to put a 5 right here. So it'll be 2,500 times 1.06 to the exponent of 5, which would give me $3,345.56. Okay. Let me see the rounding. It says round it to the nearest cent. Okay, we're fine there. All right, so you want to continue doing this formula for this, that, and that. And you notice that this one's already giving us more money 5 years later than the simple interest by about almost $100. Okay. All right, go ahead and pause it here so you can finish this rest of these. Whoa, hold on. I made a crucial mistake here. The crucial mistake that is my mistake is that the compound is actually 4.5. So, okay, this would change. All right, guys, my mistake was the interest rate for the compound interest was actually, I'm going to use green for my correction, it's actually 4.5%, so it'd actually be this wouldn't be 0.06, it'd be 1.045. That would be 4.5%. Okay, looking at this carefully, 4.5%. And also fix your formula at the top. So you want to change this number to that, and all this would be wrong as well. So let me try that again. So it'd be 2,500 times 1.045 to the power of 5 years would give me, let's see, how much is that? 2,500 times 1.045 to the power of 5. It actually gave me 3,115.45. Now you can compare. Look at this. So in 5 years, my simple interest would have gotten me more money because it's a higher interest rate. Okay, 6%. 6% beats 4.5% in 5 years. But I would like you to compare as time goes on to see what happens. Maybe this one will increase with more time. All right, so continue those and make your necessary corrections. All right. Assuming that you finish the rest of these right here, and you want to compare the two to explain what the rates can tell you about the accounts, and answer question G. What are the rates for linear and exponential functions tell you about the graphs? Okay. So remember, this one will create this kind of function, and this one will create this kind of function. So it's going to be going up slow at first, increasing exponentially later, hence the word, the term exponential. All right, looking at the next page, Leon deposits $250 in a compound interest. The interest rate for the account is 6%. So the key word here is compound interest. So you want to use the this formula, the first deposit times 1 plus the rate to the time power, except that you're going to actually be filling in a number here, which should be the 250, and the rate, which is 6%. Okay, so that'd be 0.06. And time, we don't know, so just leave it as time. So go ahead and write down your representation there. And don't forget that functions are written like f of x. But this one, we're going to put f of t because the time is the important thing here, the independent variable, the thing that's always increasing. Same thing for this one right here, number 21. And same for this guy and that one. Let me see, let me read that one a little better. Cisco deposits $500 into an 500 compound interest account. Here's the interest rate, 3.25. The function is that. Determine the account balance after each. Okay, so for this one, well, they're giving you that it's 2 years, and here is the function. Here's the 500 original, and here is 1 plus 3.25%. Notice how 3.25% is written as 1.03. So the formula is 1 plus the rate. The rate is 0.0325. See how there's a zero here because it's 3.25%. So for this one, just type in 2 for the time and use your calculator to find the total. Same for number 4. You're given the time, so put that in t and follow the equation to its end. Go ahead and do those, pause it, and continue after. All right, lastly, you're going to make another table. And this time, Yi has $700 in the deposit account, and the interest rate available for the account is 6%. Okay? So you're going to compare the same interest rate with the same amount of money for both simple and compound. Okay, just get you guys started a little bit. Okay, we'll use red and blue. The units is years probably. Let me zoom in. Simple interest. Well, that's gonna be money, dollars, big money. And then this one's also going to be in money. The expression of time. So you want to make the function in terms of t. So you're going to say, well, okay, that's going to be $700. Okay, plus 700 times 6% times t years. And on this one, you're going to use the, which formula was it? the compound interest formula, which is 700 times 1 plus 6%, which is 6 cents. So 1 plus 0.6 is 106 to the t time. And then we both start off with $700 today. So they both start with 700. And then 3 years from now, figure out what they're going to have in 3 years. So for the simple interest, it's going to be you're going to fill in 3 for t right here. So use your calculator to type 3, because 3 years times this number right here. So you notice it's 700 times this times that. It doesn't matter if you type it this times that, or this times that. It doesn't matter. It's multiplication. You can do it in any order. So you can type in your calculator. You might be able to type this whole thing, but you'd have to have these in parentheses, or make sure that you do this first. I would start here and then add 700. And for this one, you're also going to type the 3 years here. Okay, so get your calculator to do that. I'm going to do that one real quick. 700, that's what I'm typing in my calculator, times 1.06 to the exponent of 3. And I got 833.71 cents. And on this one, I'm going to get 700 times 0.06 times 3 years. That's 126 plus the original 700. I got 826. And as you can see, these are different already. So in 3 years, compounded, it's already giving me a little bit more money. It looks like about, I don't know, $7 or so. So go ahead and do the rest of those. Pause it right now. I'm going to look ahead. All right, the last one, Pablo, he has the $110. So do the same thing here. Okay. Keep in mind the interest rate here. You move the decimal point twice because you basically do this divided by 100. Okay. If you do that, you won't ever get the wrong answer. 3.5 divided by 100. That'll give me 0.035. Okay. Not 3.5, okay? Not 3.5, it's actually, you move the decimal point twice when you divide by 100. That'll be your R, your rate. All right, guys, shoot me an email if you have any questions on this, and post a comment explaining how easy exponential compound interest. Explain how easy compound interest rate is, and explain how do you plug it in the formula. What does each variable represent? And the variables I'm talking about are a to the 0, 1 plus rate, 1 plus r. I just almost gave it away there. 1 plus r to the t. So explain to me what a to the 0 is. It's a 0. Explain to me what a to the 0 is. Explain to me what r is. And explain to me what t is. Next week I'll show you why it's plus 1. Okay, that's the only thing that's kind of weird. Why is it plus 1? Somebody should ask me that. Okay, guys, good luck.